glad I'm in the water, it's hot. This is the Clark Fork River. There's another line after that. There's a lot more words after that. There's so many fish on my feet. In Montana, where I live, something. So the Clark Fork's geochemistry explains why... crap. So the geochemistry of the Clark Fork explains why acid rain isn't as devastating here as it is in, say, the Adirondack. This is about buffers. I didn't see you point at me, Nick. How do I know? Did you point at me? Do it again. Point. Point more. That's creepy. That's too much. Did you point at me?
No, I was waiting for you to stop talking.
It's not how it works. I talk forever until you point. Acid loses xm and gains, and both ions gain x. Molar x. The symbol for this kind of equilibrium constant is Ka for an acid or Kb for a base. A rate law in this form is said to be of the fourth order. We get that alu by adding val the fourth hard. A rate law in this form is said to be of the fourth order. We get that by adding together the exponents. Shut up. A rate law in this form is said to be of the fourth order. We get this value by adding together the exponents, 3 plus 1, and that x equals 4. To them, solids like my table here, or my phone, or this isn't a phone. I missed a couple of words there. So use the equilibrium expression for acetic acid and put in the Ka and the equilibrium concentrations from the rice table. So use the equilibrium expression for acetic acid and put it in the K. Put in. Your pacemaker, hopefully you don't have a pacemaker, but if you do, that too, I don't know where I'm going. Medium.
Cledium.
And another part where they're being... which is why we call these things alkaline batteries. With a little algebra, it simplifies. That doesn't look simpler. I guess you could call that simplifying, but that's... Oh, I mean, I could use the quadratic equation, but that sounds just terrible to me. So, let's show you... Ugh, that's like quadratic. I don't want to do that. So here's a little trick to make this a lot easier. Here's a little trick. A random. Finger itches. Why? Why do my finger itch? If it's so small that after rounding for significant digits, it won't change our answer. The rest of the problem cancels out, leaving x to equal 1.75 times 10 to the negative fifth. Why did I say 5?
3, sir!
It said it right there. The rest is a breeze. With a couple taps of the calculator, we find that the pH is 7.45. That's not what it says. The rest is a breeze. With a couple of taps of the calculator, we find that the pH is 7. That was too much. I didn't know where the table was. Was it too loud? Put your headphones back on. Ah! But what if we tried the push so badly that they can't be driven anymore, and the last driver of a car that continues to drive, damaging your own car, and the last... Every reaction has a minimum amount. Every reaction has a minimum amount of energy required to get it started, because it involves reactions that either produce or consume reaction. I've told you about redox reactions before, and if you haven't seen that episode yet, you should probably watch it before you watch this one. Like, for example, this kind of work. Ugh. It's not mine, I don't want to break it. Yeah! Go! Well, it's kinetic energy, the kind that comes from a particle's speed. It's actually the literal speed of the atom. So just like cars in Demolition Derby, all else... What?
That didn't work.
No? Okay. Like if you keep smashing into the back of a guy's trunk, you're not gonna stop his car from going, because there's no engine back there. And we find that the rate of the reaction is 0.012 moles. It's not very many moles. It's hard to really have 0.012 moles. Equilibrium expressions also use bracketed concentrations with exponents, and that's no accident. Now, if you've watched our episode on equilibrium, this formula should work. Now, if you've watched our episode on equilibrium, you should. No idea what I just said. I'm sure that the graphics will make it clear. Of their electrons, their chemical bonds, and their intermer... like foams and gels and colloids, like mayonnaise, rubber, waxes, and some biological tissues, such as fat. In order to do it right, you have to type molecular. Like molecular, that makes sense. Atomic solid as the solid? And I don't want to say it now, except that now that it's garnered. The diamond in this ring. Fascinatingly enough, only a few minor differences in atomic arrangement allow an element found on the bottom. Once you learn the chemistry of these different netics, both of these properties make ceramics useful in tons of ways that you've probably been exploring since you were a toddler and got your first box of modeling clay. Now, if each of these half reactions occurred in contact with the other, they'd spontaneously go to equilibrium, releasing a bunch of energy. Thanks for watching this episode of Crash Course Chemistry. If you were listening, you learned that avocational.
It's a great word.
I don't think it's a word, though.
It is now.
You learned that electrochemical reactions The script supervisor wasn't here, and Michael Aranda is our sound designer. Like how Bohr figured out his motto, or the way Heisenberg used math to usher in combustion, halogenation, and dehydrogenation.
Ooh.
And Michael Aranda? This episode was written by Edie Gonzalez, edited by Blake Deepak Chopra. The script supervisor was Michael Aranda. He was also our graphic designer. A graphic designer, apparently. The script supervisor was Michael Aranda. Why? This is the easy part. And finally, you learned that chemical reactions actually happen in steps, that the slowest step determines the overall rate of the reaction, and that the reason for that. You've also learned that I should have the teleprompter going faster. You also learned some of the properties of each of those solids, and diamond are network. You learned that both diamond and graphite are network solids made up of pure carbon atoms, but.
Good night, everybody.
Could be better.